Hello everyone, I am Vishan Singh Chaudhary, a postgraduate student of NIT Warangal. In this video, we will see the solution of pair of linear equations in two variables. It means we will see how to find out the values of x and y which satisfy the given pair of linear equations. And we will see that how many such values of x and y will exist that will satisfy the given pair of linear equations. So let's start today's video. First of all, we will consider a pair of linear equations in two variables. That is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Now we have to find out a solution for this pair of linear equations. It means we have to find out the values of x and y which satisfy both the equation simultaneously. Suppose if we put x equal to 1 in this equation and y equal to 1 in this equation, then those values of x and y will also satisfy this equation. Then only we can say that the x equal to 1 and y equal to 1 will be a solution for this given pair of linear equations. So we have to find out the solution. But before that, we have to know that how many such solution will exist for a given pair of linear equations. So let's see. As we know that a linear equations in two variable represent a straight line. That's why I call this equation as a line L1 and this equation as a line L2. Now we have two lines. Red line is L1 and yellow line is L2. Suppose these are the two lines. This is L1 and this is L2. They may intersect each other, they may parallel to each other, or they may coincide each other. So we get three cases. It means first one is intersecting when lines are intersecting each other, second one is when lines are parallel to each other, and third one when lines are coinciding each other. Now we will see that how many solutions will exist for each case. Means for intersecting case how many solution exist, for parallel case how many solution will exist, or for a coinciding case how many solutions will exist. So for that we will take first case when lines are intersecting each other. Suppose these are the two lines L1 and L2 and these lines are intersecting at this point. Consider this point as A having coordinates x comma y. It means this point A is lying on L1, so this will satisfy this equation, and this point A having coordinate x comma y is lying on L2, so this will also satisfy this equation L2. So from here we can see that this point A x comma y is satisfying both the equations L1 and L2. So from here we can conclude that when lines are intersecting each other, we are getting a single point. That point is a unique point. So we get a unique solution. So from here we get an unique solution. So when lines are intersecting, we always get a unique solution. Now we will see a second case, that is parallel lines. Means when lines are parallel to each other. Suppose these are the lines L1 and L2. If we extend this line in a left hand direction or we extend this line in a right hand direction like this, then we see that the both lines never meet each other. It means we are unable to find a point x comma y which satisfy both the lines L1 and L2. So from here we conclude that when lines are parallel to each other, then we are getting no solution. Now we'll move to third case when the lines are coinciding each other. Suppose this is a line L1 and this is a line L2. Suppose we consider a point here, then we see that this point is lying on L1 and as well as on L2. So this point will satisfy both the lines L1 and L2, means both the equations L1 and L2. If we consider a point here, then this will also satisfy both the lines L1 and L2. It means both these equations. If you take a point here, then this point will also satisfy both the equations. Then we can see that we are getting an infinitely such point that are satisfying both the lines L1 and L2, or we can say that are satisfying both the equations L1 equation and equation L2. So from here we can conclude that when lines are coinciding each other, then we are getting an infinitely many solutions. So from three cases, intersecting lines, parallel lines, or coinciding lines, we get three type of solution. First solution, unique solution. Second is no solution, and infinite solution. But can you tell me that under what condition we can say that a unique solution exists or a no solution exists or an infinite solution exists for a given pair of linear equations. Let's see. In first case, we have a unique solution. For unique solution, we see that the lines are intersecting each other. And we know that the condition of lines when lines are intersecting, that is a1 upon a2 is not equal to b1 upon b2. If we get this type of condition, then we get a straight line. And if we get a straight line, then we always get a unique solution. So for a unique solution, we get a condition that a1 upon a2 should not equal to b1 upon b2. Now we will move to second case when no solution. For no solution, we are getting parallel lines. And we know the condition for a parallel lines, that is a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2. If this condition hold, that a1 upon a2 is not equal to b1 upon b2 but not equal to c1 upon c2, then we are getting parallel lines. And if we are getting parallel lines, then we get a no solution. So for no solution, we get a condition that is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Now we will get a third case when infinite solution. For infinite solution, we have seen that we are getting a coinciding line. So for that, we have a condition that is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So if we get this condition, then we get a coinciding lines. And if we get a coinciding lines, then we know that we will get an infinite solution for that. So we get three conditions for all the three types of solution. When the when we get a unique solution, we get a1 upon a2 should not equal to b1 upon b2. If we get a no solution, then we will see that a1 upon a2 should equal to b1 upon b2 but not equal to c1 upon c2. For infinite case, we have seen that a1 upon a2 is equal to b1 upon b2 equal to c1 upon c2. So from these three conditions, we can say whether the solution is unique, no solution, or an infinite solution. But we cannot tell that what is the solution from these three conditions. Okay, so we want to find out those solutions. That is, we want to find out the values of x and y which satisfy the given pair of linear equations. So we will see. First, we will see that by graphical method. After that, we will see an eliminating method. That is a very convenient method to solve that pair of linear equation. So first method is graphical solution for a given pair of linear equation. We will see this by an example. So we have a question like Rahul went to an stationery shop and purchased 4 pencils and 3 erasers for rupees 24. And his friend Shivam sold the new variety of pencil and erasers with the Rahul, and he bought 2 pencils and 5 erasers of the same kind for rupees 26. Now represent this situation algebraically and graphically and find out the solution. So now what question says? Question says that there are two friends, Rahul and Shiva. They both went to an stationery shop where Rahul purchased 4 pencils and 3 erasers for rupees 24, and Shivam purchased 2 pencils and 5 erasers for rupees 26. Now we have to represent all this situation algebraically as well as graphically, and we have to find out the solution. Okay, so now let's do the solution for this question. First of all, we will consider a pencil and a eraser. So consider denote pencil by x and eraser by y. Rahul purchased 4 pencils and 3 erasers for a 24 rupees. It means the cost of pencils that he spent, that will become 4x, and the cost of eraser that he spent, that will become 3y, and 4x plus 3y will become 24 because he totally spent 24 rupees for 4 pencils and 3 eraser. So like that we will get first equation. Similarly, in Shivam case, Shivam purchased 2 pencils, then the cost of 2 pencil will become 2x, and he purchased 5 erasers, then the cost of 5 erasers will become 5x, and the total cost is 26. So the equation will become 2x plus 5y equal to 26. So we get two equations. Now we have to find out a solution for this equation. First of all, we have to represent this equation graphically. So we will represent equation 1 first graphically. After that, we will represent equation 2. After that, we will combine both the graphs and we will see the how to find out the solution. So graphical representation of a line 1. For line 1, we will put x equal to 0. Then we will get the y equal to 8. And if we put y equal to 0, then we will get x equal to 6. So from here, we get 2 points. That is 0, 8 and 6, 0. Then we will join both the points on a graph. Then the graph will look like this, a straight line, where B point that is 0, 8 and we are getting A point that is 6, 0, and we are getting y equal to 24 minus 4x by 3. So now we will see graphical representation of line 2. So we have x and we have y equal to 26 minus 2x by 5 by applying some algebraic operations. And if we put x equal to 0, then we will get y equal to 26 by 5. And if we put y equal to 0, then we will get x equal to 13. So from here we get 2 points, 0, 26 by 5 and 13, 0. Then we will join both the points. Then the graph will look like this. D point that is 0, 25 by 26 by 5 that is 5.2, and C point that is 13, 0. Now we will combine both the graphs, graph 1 and graph 2. Then the graph will look like this. This line represent equation 1 and this line will represent equation 2. Here it is a point B and point A where equation 1 intersecting y-axis and x-axis respectively, and it's a point D and a point C where equation 2 cut the y-axis and x-axis respectively on point D and on C. So you can see that these both the lines are intersecting at a point E that is 3, 4. And we know that when both the lines are intersecting, then we get a unique solution. Hence, we are getting a single point, then this point will be our unique solution. That is, from here, we are getting a unique solution that is 3, 4. 3, 4 will satisfy both the equation 1 and equation 2 also. So let's put x equal to 3 and y equal to 4 in this equation. That 4 into 3 will become 12 and 3 into 4 will become also 12. So 12 plus 12 that will become 24. So equation 1 is satisfied. Now we'll put in this equation, put x equal to 3 that is 2 into 3 6 and y equal to 4 that is 5 into 4 that will become 20. So whole will give 26. So equation 1 and equation 2 both are satisfied with this point. So we are getting a unique solution that is E equal to 3, 4. Now we will verify this by a ratio method. So for ratio method, the given pair of linear equations are 4x plus 3y into 2x plus 5y equal to 26. So from that ratio method that we know that the value for the condition of unique solution is a1 upon a2 is not equal to b1 upon b2. So first of all, we want to find out the values of a1, a2 and b1, b2. So we will compare this equation with the standard equation that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. So from there we get values a1 equal to 4 and b1 equal to 3 and a2 equal to 2 and b2 equal to 5. So we will see. Now we will check the condition of a unique solution that is a1 upon a2 should not equal to b1 upon b2. Now here we are getting 4 upon 2 should not equal to 3 upon 5. Now we'll cross multiply it 4 into 5 and 3 into 2. So 20 will never equal to 6. So this is a true statement. So hence the ratio method is verified. So from here we can say that we are getting a unique solution for the given problem, and that is E equal to 3, 4. Now we'll move to a next method that is elimination method, and this is a very important method. So please concentrate on this. So elimination method to solve a pair of linear equations in two variables. For we have a pair of linear equation that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Now for elimination method we follow certain steps. So the step one is like that we have to multiply a certain non-zero number to L1 as well as on L2. So the coefficient either of x or y will become equal. Suppose we multiply this equation by A2 and we multiply this equation by A2 and we will multiply this equation by L2 equation by A1. Suppose we multiply this equation by A1, then you can see that the coefficient of x will become same, a2 into a1 and a1 into a2. So both are numbers, so the coefficient of x will become equal. So first step is like that. First we'll multiply both the equations with some suitable non-zero constant to make the coefficient of one variable numerically equal. Here you can see that we are making the coefficient of x equal, that is a2 into a1. Now after that, for second equation, we will either subtract or add either equation from L2 to L1 or L1 to L2. So add or subtract one equation from the other, that one variable will get eliminated. And after that, we will find out the value of the remaining variable. In third step, we will solve the one variable and we obtain its value. After that, we put the value of that equation in the given equation. Value of that variable in the given equation, either in L1 or in L2, to get the value of another variable. Substitute the value of x or y either in the of the original equation to get the value of other variables. So we have to follow four steps. First one, to multiply a non-zero constant to make the coefficient of either x or y equal. Second one, either add or subtract one equation from the another equation to get one variable eliminated. And third equation, to solve the one variable and get its value. And the fourth equation substitutes its value of x or y in either of the original equation to get the value of other variable. Now we will see some examples based on this elimination method. So use elimination method to find out all the possible solutions of the following pair of linear equations. So the equation is 7x plus 2y equal to 9 and 14x plus 4y equal to 29. Now we have to find out the values of x and y which satisfy this given pair of linear equation. And we have to follow the elimination method. Remember this, we have to follow the elimination method. So given pair of linear equations is 7x plus 2y equal to 9 and 14x plus 4y equal to 29. Call this equation as equation 1 and this equation as a equation 2. Now we want to make either of the coefficient of x or y equal. So we will multiply equation 1 by 2 and we will multiply equation 2 by 1. So we have to use elimination method for this question. So we'll multiply equation 1 by 2 and equation 2 by 1 to make a coefficient of x equal. So we get 14x plus 4y equal to 18 and 14x plus 4y equal to 29. Now we will subtract equation 3 from equation 4 to eliminate the variable x. Okay. So now we will subtract equation 3 from equation 4 to eliminate the variable x. But from here we can see that both the variables x and y are eliminating and we are getting 0 equal to 11, means this statement is false. 0 never be going to equal to 11. So this statement is a false statement. So we get no solution for this given pair of linear equations. Here I forget to mention a point that when we are subtracting or adding a one equation from other to eliminate one variable, if both the variables are eliminated and if we get a true statement, then infinitely many solutions exist. If we get a false statement, then no solution exists for the given pair of linear equation. Remember these 2 points. The first point is that if we are getting a true statement after eliminating both the variables from second step, then we are getting an infinitely many solution. If we get a false statement, then we will get a no solution for the given pair of linear equation. So from those 2 points, we get a no solution for this pair of linear equations. Now we will see in another question that a ratio of income of two-person is 9:7 and the ratio of their expenditure is 4:3. And if each of them manage to save 2,000 rupees per month, then find their monthly income. So first we will see what is question 1 to say. That there are two persons. Consider this person as X or Y. No, so that but there are two persons. So their ratio of income is 9:7 and ratio of their expenditure is 4:3. And in the end of month they are able to save 200 rupees per month. And we have to find out the monthly income of both the persons. So now we will consider income by X and their expenditure by Y. So the income of person will become 9x and 7x respectively, and their expenditures will become 4y and 3y. And as we know that if you are getting 100 rupees and if you spend 80 rupees from those 100 rupees, then you will see that you have 20 rupees left. It means you are able to save those 20 rupees. It means we have to apply that formula. It means we will subtract expenditure from income to get a value of save account of save rupees. So we will subtract 4x 4y from 9x to get 2000 rupees for a first person, and we will subtract 3y from 7x to get 2000 rupees for a second person. It means we will subtracting the expenditures from my income to get the value of saving amount. Okay, now we have two equations, equation 1 and equation 2. We will solve these two equations by using elimination method. So first of all, we will make the coefficient of y equal. So we will multiply the coefficient of the equation 1 by 3 and equation 2 by 4 to make the coefficient of y equal. So we get 27x minus 12y equal to 6,000 and 28x minus 12y equal to 8,000. So we will subtract equation 4 from equation 3 to eliminate y, to eliminate variable y. So from here we will get 28 minus 27, that is x, and 8,000 minus 6,000, that will become 2,000. So we will get x equal to 2,000. Now we will put this x equal to 2000 in our equation 1. That is 9x minus 4y equal to 2000. That is 9 into 2. That is 18,000 minus 4y equal to 2000. So we will get 4y equal to 16,000, and after that we will get y equal to 4,000. So we get the values of x and y. It means these values x equal to 2000 and y equal to 4000 will satisfy the given pair of linear equations. But we don't have to find out these values x and y. We have to find out the values of income. So the income was 9x and the income of second person was 7x. So the income of first person will become 9 into 2000, that is 18,000, and the income of second person will become 7 into 2000, that is 14,000 respectively. Now we have seen in this video first the type of solutions for a given pair of linear equation. After that we have seen the graphical method to solve a given pair of equation. After that we have seen the elimination method to solve the given pair of linear equation. So this is about the solution of pair of linear equations in two variables. Thank you.